Welcome to Dare, the show for startup leaders, innovators, and entrepreneurs who dare to shape the future. Dare is brought to you by the Oregon Entrepreneurs Network, OEN, and Darwaft, the superpower tech team that can make your vision a reality. The Dare podcast is excited to welcome Susan and Joe Piacenza to the show. They are the CEO and COO, respectively, of SeaStereo. So we're excited to hear about their work there and what they're doing to do AI modeling and statistical modeling to measure livestock size and biomass for aquaculture. So it's an exciting new domain. I don't think we've had a startup on the show before that's talked about aquaculture. So lovely to have you here.
Yeah, thanks.
Thank you.
So tell us, how did SeaStereo get going?
Well, it's a little bit of a long story, so I'll try to keep it short. But it all started quite a few years ago now. Joe and I were just both getting started as faculty at a university in Florida. One of my study species are working with sea turtles, and I was interested in trying to find a way to study them using UAVs or drones. And still am interested in measuring them at large in the ocean. So trying to find them over larger areas of the ocean. If you're trying to do it from boat or scuba, you might not really encounter that many individuals.
Yeah, well, my main exposure to sea turtles is Finding Nemo. So I know
Yeah.
nothing about sea turtles.
Yeah.
But yeah, so you founded this company to do that kind of work to understand behavior in the oceans.
Yeah, so it really started from the standpoint of how, something that we need as marine scientists to study our animals in the wild, right? And we fast forward to us coming to Oregon State University in 2021, and we were participating in the Advantage Accelerator program here to help kind of get this thing off its legs, just and to go from research focus to more of a, commercialization. And so we were looking at our target market, and we quickly realized that kind of like the marine science market is pretty small, and so we were looking for something that would be very similar but would has a much bigger reach commercially. And so that really kind of led us to aquaculture, which is kind of just like a near neighbor to what I do as a marine scientist. So
Well, just very briefly, if you could explain to our audience, what is aquaculture?
yeah, so aquaculture is seafood farming. So anytime you're taking an aquatic species, and it could be freshwater or saltwater, and you're trying to raise it in a tank or a pond or a pen in the water, that's aquaculture.
So creating, or I should say, domesticating sea life so that we can use it in some way, right?
Right. Yes.
Fantastic. So where do you fit into this, Joe?
I'm just the engineer. Susie's got the vision for the whole thing. But yeah, I can expand on that. So again, when we were back at the university in Florida, one of the barriers to doing these surveys for sea turtles was that most of or I should say, all of the commercial equipment was for divers underwater with the hardware and the software. And so that was when collectively we kind of had this brainstorm. Well, what if we could have the same level of accuracy of going out on a boat and diving in the water and measuring a sea turtle from the air, right? Where we could cover a much bigger area, use less resources, and if we could do this just efficiently. And so yeah, Susie and I brainstormed initial prototype, again, almost 5 years ago now. And then since then, we're on our fourth iteration, both in the hardware and the software domain. And then just thinking about advances in machine vision and AI, we've recently incorporated that in the past year and a half. And so the landscape of both the hardware and the software is a lot different than it was 5 years ago when we started.
Got it. Well, Susan, if you could briefly describe your solution as you've commercialized it, because I know you had a beginning back in, it sounds like 2021 or even earlier in terms of ideas, but now you have kind of commercial products out there, right?
Yeah, we're working on kind of testing it with real aquaculture operations right now. Yeah, so the way we have it organized is it's like a 3-tiered approach. So we have the hardware system, which uses stereo cameras and different mounting systems. So it could be on a UAV, or it could be some other kind of mount, like a fixed mount or like a gantry, really kind of thinking about all the different types of aquaculture facilities there are. There are some that are tanks indoors where really flying a drone doesn't make sense. Big ponds outside. Like I said, in some places in the world. Net pen aquaculture, like Norway and Scotland, is really big. So there's a lot of variability in the types of facilities, but different hardware solutions. Then software that's AI driven that will automate identifying which the individual livestock, whatever you're trying to rear. So fish, oysters, crab, things like that. And then automates the measurement of them. And then once we have the link, we can then put it into a statistical model that then predicts the weight or the biomass of the individuals. And then if you have counts, you know how many animals you have in your tank or pond, then you would also know the biomass. And then all that information can be used to monitor the health of them. Are they growing at the rate that you want them to grow? You can use it to adjust your feed rates. So you can be like, okay, I know how much food to give them. I'm not going to waste my food or not give them enough. And then one of the other advantages of is it can save your labor, because instead of hand measuring individuals and taking them out of the water, it's all happening with the system. And so you're protecting your animals. They're not getting stressed. They're not being handled. And then also it can lower your labor costs too.
So is this all being done by information that's collected with a drone that's flying over in the air?
It can be, yeah. Like I said, it can be drone mounted, but we have other mounting solutions that could be, like I said, it could be more of a gantry system, kind of like Joe has a good analogy for that. Like
a 2D printer
yes,
instead
yeah,
of the
Got it.
third dimension going up and down like a
yeah.
crane system. Yeah, and that actually came out of some testing we did at the Oregon Coast Aquarium here, where we had one of our drones inside. And while it is nimble and fit within the physical space, we were having issues with just the inherent proximity detection of the systems and GPS being in a big metal warehouse, which is like a Faraday cage. And so that's when we kind of went away from the drone for the indoor use and kind of came up with this 2D system, right? So now we can actually move our stereo camera system in transects across the tank. So if animals are clustered in one space, for example, we can make sure that we're getting good visual measurements.
So I've also heard of underwater drones being a thing now. So is that something you're also exploring?
Not at the moment, while it's not impossible. So thinking about our value proposition and some of the other competitors in the space is that there's downsides of the underwater equipment and that it's in the water. And so it's susceptible to biofouling. It also has a relatively narrow field of vision, right? So most of the competitors are looking at animals that are about 1 meter away from either the singular or more than one camera lens. And so subsequently, they have to get the fish moving past their fixed system. We haven't seen any underwater roving vehicles in the aquaculture setting yet, but that's one space where we really add value, is that our camera system can be above either via the gantry or the drone or even a fixed mount above the tank. And so our field of view is much better. And then also, Susie can explain this better than me, but thinking about looking down on the fish, you can estimate biomass really well by how wide they are, right? So Susie always says, like humans, when fish get heavier, they get wider, right? When they get older, they get wider, right?
Yeah.
They don't necessarily get longer always.
I don't know. I mean, I am feeling kind of wider after all COVID eating. So thanks for pointing that out,
Exactly.
Joe.
Yeah, so fish are the same.
Got it. So I know Joe kind of passingly mentioned other competitors in the field. Susan, do you want to tell us what the landscape looks like for people working in aquaculture in this capacity?
Yeah, well, it's kind of the same theme in the sense that our understanding is there's a lot of variability about how people are doing it right now. So
Mhm.
we've interviewed a number of companies, and a lot of them are still kind of doing it in like we call it the fish in the bucket method, where they'll take out and count so many fish. Since they're aquatic animals, they need to stay in the water. So they'll put them in a bucket of water. They know how heavy that bucket of water is. And they're like, okay, I added 10 fish. The weight of that bucket of water just increased this much. So I'm going to take that weight, divide it by 10, and that's my average size of my fish. And I'm
Oh,
keeping
really?
track of how many individuals I have. So take the average size times the number of animals, that's your biomass. So that's kind of
That seems really rough.
it's very rough. Yeah. And it can be, I've talked to some people that at fish hatcheries where they can have a lot of size variance. So they'll have like
Yeah.
juveniles and adults like together. And so it would be really easy to, if you happen to just get the 10 easiest fish to catch that day, that could, that you might catch a lot of big ones or a lot of the small, slower ones.
Yeah.
But there are some other companies
Now
out there.
that could be off by a significant factor. So what you're
Yeah.
doing is adding both machine learning and additional camera work that can be much more precise, it sounds like.
Yes. Yeah, exactly. And there are some other companies out there that are trying to do some kind of similar approach, like this kind of precision aquaculture to help fish farms go or seafood farms go from this kind of, like I said, the fish in the bucket method, increase sample size and accuracy, but they all, like Joe said, have camera systems that are positioned underwater. We think that there's some improvements that can be made from that type of system to having your camera mounted externally and looking down. One of the
Right.
things that can happen is if you have a camera underwater is it actually can change fish behavior. They're always attracted to any kind of structure in the water. And so sometimes you can get animals that are going to kind of like swarm the camera and make it hard to see an individual because they're like too close, or you just can't, they're like kind of overlapping each other. Some species will behave the exact opposite way and like avoid the camera because they perceive it as like something bad, like
Threat.
threat.
Yeah.
Yeah. And like Joe mentioned, there's problems with having like expensive electronic equipment underwater and saltwater. You're going to have the lifespan's going to be limited. There's biofouling, like algae and stuff will grow on the lenses and just on the power cords and stuff like that. So we think that there's added value by doing the kind of top-down measurement.
Right. So you're doing all this measurement. You're getting a closer to accurate measurement of the biomass and of the fish or turtles or whatever you're keeping alive in that tank. But I'll ask the big question. Why does this matter? Why does aquaculture matter? And why will your company have a market there?
Yeah, that's a great question. And that's one of the things that I think that we get most excited about, and I do, especially because I am a marine scientist, is how important, having a sustainable supply of seafood is. Really healthy, rich source of protein. We have very sensitive wild stocks of fish that can have very limited quotas, what really is safe to take to ensure that that population is going to be there year after year. And aquaculture is a way to provide seafood to everybody in the world. I grew up in Minnesota and I didn't really have any exposure to seafood other than walleye. So the idea
Yeah.
of there being seafood farms in the middle of America that is like anything other than walleye is not my favorite growing up. I think really exciting. So it also increases accessibility to seafood too. Yeah. So kind of going from the big picture, like ensuring healthy, like food supply everywhere in the world. It's hard to do, and aquaculture has a lot of inefficiencies. They have problems with fish loss where animals will die before they're ready to be harvested, and high labor costs, high feed costs. And so we're helping that by helping aquaculture seafood farms become more efficient. It will make it easier for them to be successful and really bring, like I said, a sustainable food supply to people anywhere in the world.
Right. I've also read some articles that have pointed out that the biomass in the ocean is significantly undercounted. Can you speak more about that conundrum?
Yeah, well, that's a good question. Yeah, this is one of the things that I really spend a lot of time thinking about is how to improve monitoring and assessment of marine species. It's something I think of a lot about, not just like in the SeaStereo context, but just generally how do we improve monitoring and assessment of what we have out there. And it's really hard to do. Somebody famously said that counting fish is just like counting trees, except they're underwater and they move around and you can't see them. And it's really hard to do. And it's really hard to get equipment to the places you need to be to sample your whatever you're trying to study, fish, corals, seagrass, everything that we hear about in the ocean. It's hard to study.
In my understanding is most of the tools that we have to date, maybe with the exception of SeaStereo, are pretty coarse tools.
Yeah, in some ways, we've been doing the same thing for a long time. One of the key ways we monitor fish stocks on the US is through a trawl survey. So like in fishing, we drop big nets and run them along the seafloor and see what's in the net and count and measure things. So we've been doing the same thing for years, which isn't bad. It's actually good in terms of having a time series of data where the methods are the same. But there's really been a big explosion of technology that is really starting to open up our understanding of what's happening in the oceans.
Right.
Through a lot of different types of technology, not just stereo vision and drones. But it really is an exciting time to be a marine scientist because we're learning so many new things about so many different places in the ocean. But
Yeah, and I guess one of the exciting things about that is if you don't know something is there, you can't fight to preserve it or make it better because you don't actually know what you're doing or what you're polluting. But if you
yeah.
actually have a good vision of what you're destroying or the fragile ecosystems that you might be impacting, then you can make decisions based on that, and you can actually have a culture or an aquaculture that you're defending for the future.
Yes, I couldn't agree more.
Yeah.
And a good example of this is we used to think that there wasn't a lot of marine life in the really deepest parts of the ocean. And what
Hmm.
we're finding through ROV surveys and other ways is that actually it's a very highly diverse, there's a ton of life in very deep parts of the ocean. So that go back to your question about how we're finding out there's actually more biomass. There's large areas of the ocean we just thought were void, and in fact finding out is teeming with life. So
Right. And also, one thing that I've read about is that when you do a huge net that just scooping up fish and then trying to count them and saying, okay, we scooped a mile. So therefore, if we just multiply that, what you're doing is you're counting the dumb fish, the ones who got caught in the net. All the ones who were wise enough to see it coming or figured it out or had a strategy or were small enough to get through the net, those
yeah.
are the ones you're never going to count because you don't know there at all.
That's a good point.
Yeah, it's a classic problem that can be addressed. Well, classic in terms of machine learning and AI is kind of built to address this because the kind of statistical analysis methods that undergird AI and machine learning are built for solving for unknown quantities, right?
Yeah. One of the things I'll mention too, going back to Susie's earlier point about, why we chose to use the technology specifically for aquaculture is that, there is a food shortage on the planet, right? And there's
Mhm.
only so many resources to go around. And so thinking about things like cattle farming and even, farming in the central coast of California, which creates so many challenges in terms of getting water there. So now we've got this opportunity to responsibly create a natural protein source for not only in the US but outside of the US. And that's something that is really inefficient at the moment. It seems like it's such a great idea, but looking into the literature, the mortality rate of aquaculture facilities is almost 50% in some cases. And so
Not good numbers.
you
Yeah,
would be hard pressed to get anyone to invest in a company, at least today, where that was only half of your crop survived, right? So
right,
that's
right. We're going to lose half our product all the time. Invest in us, please.
yeah, exactly. No, it
So,
doesn't make sense.
so if you can raise that to 75% or 80% or higher, then your technology can really make a difference.
We hope so.
But yeah,
Yeah.
that's the hope for sure.
So Susan, what's the next stage of growth for your company? I know you came out of academia and you've now kind of built on the current wave of machine learning and AI and drone. All of those things are really growth areas of technology. But what's the next stage of growth for your company's ascendant?
Yeah, that's a great question. Well, one thing we're focusing on right now is we have a really strong concept system, but what we really want to do is work with some strategic aquaculture partners and really test the system with them and really see like what's working and what do we need to modify and how we have the whole system designed as it is. To, like I said, there's a lot of variability. What we see is there's a lot of variability in aquaculture. So, can we create a system that's going to be a good fit for salmon, urchins, a lot of different organisms that might have different kind of aquaculture systems themselves? How do we make our system really robust to all those differences? So it's going to be a good value to a lot of different customers. So that's one of our big pushes this year is getting these kind of like I said, our strategic partners for testing, and then hopefully get out there pretty soon and really have an actual product for sale.
That would be very exciting. So what do you have a vision for what that actual initial product would be? Would it be like a drone in combination with the software package or
Yeah, we've kind of envisioned it for now, like I said, which is of course up for redesign with our strategic partners, is you have your mounting system, depending on what kind of facility you have. Do you need the UAV or do you need, like I said, some kind of other type of mounting system?
entry or something like that?
Pantry or whatever, yeah, and then we would work with them together to get the camera system going so they would understand how to use it, and then we would have, like, software and tech support for them, like, on the back end, so they can do the filming, and then all that goes, like I'm the biologist in this, so to me, it's like, then it just goes up into the cloud.
And then
True,
it gets handed off to Joe to manipulate the data and
Yeah,
understand. Yeah,
exactly.
got it.
Exactly. But the one of the key things we've been focusing is having like a very user-friendly kind of user interface for them that outputs like the information that they really care about, like on, on like an iPad screen or something like that. So it'd be like, here's the status, here's your biomass, here's your growth rate. You can even calibrate it for what your feed rate would be, what you need to, how much
Right.
you give them for a day. So the kind of getting them the key information that they need, that data within minutes of conducting the analysis.
Fantastic. Well, that's really fascinating where your company is at and where you're going next. Can I just finish out our conversation by asking you what you both dare to dream? I'll start with Joe and then wrap up with you, Susan. And I already have a sense of what you're daring to dream with your company, but maybe we could go even bigger than that. So, Joe, any big dreams to share with us?
Thank you. Well, yeah, I mean, again, kind of going back from the origin story, right? Is that using technology that's, emerging, as you say, very active areas to, truly make a dent in the global food supply, right? So bringing resources to areas that wouldn't necessarily have the infrastructure or the knowledge base to set up aquaculture, and being able to provide them with information to somewhat automate the process. And as Susie said earlier in the conversation, bring these distributed aquaculture facilities to locations that otherwise may not have access to them.
Fantastic. Anything to add to that, Susan? What's your big dream?
Well, this is kind of thinking down the road. So hopefully, everything we've just talked about becomes like fantastically successful. And, one thing we talk a lot about is like all these other ideas we have for how we can kind of see stereo would be not just this one, what we call the visual measurement system, to a lot of other technology that would support any kind of underwater measurement or anything related to like aquaculture, marine science, kind of being a hub for that. So I would love if we were able to, really expand beyond just this one system too. Because I think there's a lot of really cool stuff that we can do in terms of technology that really aids conservation and management of aquatic natural resources.
Well, spoken like a true CEO. She has a big vision to go around the world and take over all management of this type of information. So, fantastic vision. Thank you, Susan and Joe. Really interesting product, and I wish you all the best at SeaStereo.
Thank you
Thanks,
so
Nick.
much. Yeah, thanks for having us.
Thanks to our guests today for their insights into the entrepreneurial ecosystem. We wish you all the best in your startup journey. The Dare Show is brought to you by the Oregon Entrepreneurs Network and by Darwaf, the superpower tech team that can make your vision a reality. Visit us at oen.org or at darwaf.io. Thanks again for listening. Till next time.